All science is either physics or stamp collecting. That's what Ernest Rutherford, the legendary discoverer of the atomic nucleus, used to say. Now, we don't want to offend the chemists or the mathematicians, but let's be real. While math might be the queen of sciences, physics has always been the marshal leading the charge in this kingdom. Without it, humanity doesn't move an inch. Today, I want to take you on a deep dive through history to show you how physics literally built our civilization. Every gadget you love, every advanced medical tool, and every piece of technology you take for granted was born in the minds of egghead physicists. Einstein put it perfectly: the most practical thing you can have is a good theory. Think about the world we live in. We're surrounded by steam engines, combustion engines, refrigerators, lasers, and smartphones. We're even looking at quantum computers and the conquest of space. These things didn't just appear out of nowhere. They were dreamed up by passionate naturalists, English gentlemen, brilliant orphans, and lovable weirdos who dared to ask the deepest questions about how nature actually works. The story of physics starts with something surprisingly dark: the art of war. Historically, the first major breakthrough in physics was the description of motion. Why? Because rulers wanted to conquer, and to do that, they needed to know exactly where their cannonballs would land. For centuries, humans were clueless about trajectories. In the early Middle Ages, people actually believed a projectile flew in a perfectly straight line until it just fell straight down. It wasn't until Galileo and the dawn of modern physics that we finally understood the curve of a flight path. The 16th century was a turning point. Swords and pikes were out, gunpowder and cannons were in. The Royal Society of London, one of the oldest scientific institutions in the world, spent an enormous amount of time obsessing over gunpowder, recoil, and metal casting. But here's the cool part: those military problems led to breakthroughs in things that had nothing to do with war. They led to the study of gases, elasticity, and the very nature of explosions. Then came the Industrial Revolution, the second great leap for our species. In 18th century England, they ran out of wood. They had burned the forests for fuel and ships, so they had to start digging deeper and deeper for coal. But the deeper they went, the more the mines flooded. Horses weren't strong enough to pump the water out fast enough. That's when the Newcomen engine and later the James Watt engine stepped in. These steam engines didn't just save the mines, they changed everything. Suddenly, we had factories, railroads, and ships that didn't rely on the wind. Interestingly, the ancient Greeks were actually playing with steam prototypes way before us. They had Hero's engine, a spinning steam turbine, and even automatic temple doors. But they didn't care about practical applications. To them, theory was for the mind, and work was for slaves. Imagine if Julius Caesar had conquered Europe on steam trains. History would have looked completely different. But instead, we had to wait 2,000 years for the steam engine to return and launch the modern world. The next chapter was the era of the invisible: electricity and electromagnetism. This was topped off by the genius of James Clerk Maxwell. He discovered that electromagnetic waves were the key to everything. Today, every single electronic gadget in your house is governed by Maxwell's 4 equations. Then Michael Faraday discovered induction, giving us the electric motor and the generator. Our civilization was being electrified, moving from the mechanical to the digital. But the real mind-bending stuff started with quantum mechanics and relativity. These fields are way beyond our common sense. You need a certain type of person to break through those stereotypes. Someone like Einstein, who wasn't afraid to dive into the unknown. Quantum mechanics is now the foundation of our entire IT and optoelectronic world. It's what's going to build the future. But before we get to the future, we have to look at two specific examples where physics changed your daily life in ways you probably never noticed. Now, let's look at two specific examples where egghead physics changed your daily life in ways you probably never noticed. The first is something you likely use today: GPS. Most people think Albert Einstein's theories of relativity are just abstract math for textbooks, but without them, your smartphone wouldn't be able to find a pizza place across the street. GPS is pure physics in action. The system relies on a constellation of over 24 satellites orbiting 20,000 kilometers above us, moving at speeds of 14,000 kilometers per hour. Because they are moving so fast, and because gravity is weaker up there, time actually flows differently for those satellites than it does for you on the ground. This sounds like science fiction, but it's a cold, hard reality. Einstein's special relativity tells us that since the satellites are moving fast, their onboard atomic clocks tick slower, by about 7 microseconds a day. At the same time, his general relativity says that because gravity is weaker high above the Earth, those same clocks actually tick faster, by about 45 microseconds a day. When you do the math, there's a net difference of 38 microseconds every single day. It doesn't sound like much, right? But light travels fast. If engineers didn't program Einstein's equations into the system to correct for that tiny time gap, your GPS would be off by 11 kilometers by the end of the first day. Instead of finding your house, your phone would tell you that you're in the middle of a forest 3 towns over. But physics didn't just give us the map, it gave us the network. The second big gift from physics is the visual internet, the World Wide Web. In 1989, a man named Tim Berners-Lee was working at CERN, the European Organization for Nuclear Research. While particle physicists were busy smashing atoms together in giant colliders, they were drowning in data. They needed a better way to share information across different countries and different computers. Berners-Lee proposed a hypertext system to link documents together. His boss famously called the idea vague but exciting. Using an old Steve Jobs Next computer, which had a sticker on it that said, "Do not power down. This is a server," he created the first web browser and changed the world forever. The internet we know today wasn't born in a marketing office. It was a side project born from the sheer necessity of handling physics data. This brings us to a mind-blowing realization about where we're heading. If we look at the timeline of our progress, it's not a straight line. It's a rocket ship heading straight up. Since Isaac Newton published his laws of motion, only 300 years have passed. That is nothing. For nearly 1 million years, our ancestors used the same stone tools with almost zero upgrades. 1 million years of stagnation, followed by a 300-year explosion of physics that took us from horse-drawn carriages to the moon. Some futurists, like Ray Kurzweil, believe we are approaching a technological singularity. This is the point where progress happens so fast that our human brains literally won't be able to keep up or even predict what happens next. We are seeing exponential growth in everything, from the power of our processors to our understanding of the quantum world. As we learn more, we learn faster. It's like a snowball rolling down a mountain that is quickly turning into an avalanche. But let's zoom out even further for a second. The great Carl Sagan once asked what a civilization looks like when it reaches 1,000,000 years of age. Our technical civilization is only a few hundred years old. Compared to 1,000,000-year-old society, we are like ants or macaques looking at a skyscraper. We've only had radio telescopes for a few decades. If we've done all this in such a short window, imagine the physics that will be possible 1,000 years from now. We are living in the most exciting era in human history. We are the generation that gets to watch the curve of progress go vertical. From the trajectory of a cannonball to the strange, ghostly world of quantum computing, physics has been the quiet engine driving every major leap our species has ever made. It is the ultimate tool for understanding our past and building our future. So, next time you look at your phone or check your location on a map, remember the Jajaglowy physicists. Remember that you're carrying a piece of the cosmos in your pocket. And remember that the most exciting discoveries are likely still ahead of us, waiting in the dark, just beyond the reach of our current theories. Thanks for listening, and don't forget to stay curious.